One second, sir. It will. Screen not okay. Screen visible, sir, now?
No, sir.
No, it is not visible.
नो विजिबल सर, सिर्फ आपको दिखाई दे रहा है सर.
Here, share.
Sir, visible now?
Yeah. Now it's okay now, sir?
Yes, sir.
So in that principal quantum number, we said about the shell. In that azimuthal quantum number, in the shell, how many subshells are available? So K shell, only one subshell available, that is called the S subshell. And the L shell are having two subshell. One is a S subshell and another one is a P subshell. And the M shell having three, S, P, and D. Next N shell having S, P, D, and F. So overall 4 subshell. So L value of K shell only 1. That means 0. And next L value, L shell 0 and 1. Next M 0, 1, 2. Next N 0, 1, 2, 3. That means K shell only one subshell available. The L value will start.
Principal quantum number.
It is 1.
No, sir.
Network issue. No.
हेलो ये मिनी रिबा का नंबर है क्या? हेलो
Hello, sir.
हेलो
Someone speaking.
हेलो हाँ सर अभी ठीक है सर
ठीक है
No
कंटिन्यू करिए।
visible.
सर परमानेंट के लिए सॉल्व कर दीजिए ये बीच बीच में चल से
सर फिर से शुरू से एक बार कीजिए, आगे का सुनाई नहीं दे।
Now it's okay, no? It is visible. Suppose if it is not visible, once inform me, and then I'll continue with that.
सर प्लीज रिपीट सर
Uh, from the beginning.
यस सर
Okay. Yeah, the first question they asked in the modern periodic table, and the period indicates. So in when you are taking the periodic table, yesterday we discussed column everything is called a group, and the horizontal rows is called a period. Okay, no. So first period we are writing only 2 elements. Second period 8 elements. Third period 8 elements. So how they are arranging the elements? So based on the principal quantum number, how we can identify this is the principal quantum number only. Then yesterday itself I said first period element everything it will accommodate the electron in K shell only. It won't accommodate beyond that. It won't accommodate beyond that. That means hydrogen if you'll write a 1s1 and helium if you'll write a 1s2.
वन इज
This is hydrogen and this one is a helium. So you know that. So the K shell indicate first shell. First shell means the number n value equal to 1. N is nothing but principal quantum number. So that's why we are writing the principal quantum number is the answer. Suppose if they would have given the azimuth quantum number or azimuthal quantum number or angular quantum number, then how we can able to identify. So that is the next part. Principal quantum number means n, and magnetic azimuthal quantum number means L, and magnetic quantum number means ml, and last spin quantum number means s. This value, the quantum number, how we can able to identify and how we can find out the values. If it is the shell is, this is nothing but shell, and L is nothing but shape. How the subshell or how the orbitals, it is shape, and ml is the orientation. And s is the spin quantum number. Now n is the shell. Now you are taking one nucleus is the first shell, and this one is the second shell, and this one is the third shell, and this one is the fourth shell. So here we are writing as a K, that is first shell. From the nucleus, first shell, that's a K shell, and from the nucleus, second shell, L shell. From the nucleus, third shell, M shell, and from the nucleus, fourth shell, N shell. Now this is nothing but the value. K means 1, L means 2, M means 3, and N equal to 4. So the first period element, everything having the number of the shell only 1. Second period element, everything having number of the shell 2. Third period element, everything having number of the shell 3. Fourth period element, everything number of shell 4. So like 7 period, 7 shells will be available. So this is the first case. Second one, in that shell be written in the particular shell how the subshell will be available. So subshell means as a shape of the orbital or a subshell. Shape means we are writing S subshell, P subshell, D subshell, and F subshell. If it is S subshell means only one orientation as a spherical in shape, is a spherical shape. Second one is a P subshell, it's a dumbbell shape. And next one is the D subshell, double dumbbell shape. 2 dumbbell will be oriented in the one particular point. And the F means 3 dumbbell shape will be available. The first and second and this one is the third. So overall 3 dumbbell shape. This is nothing but L. So that's why we are saying L equal to 0. Why? Because it's a non-directional. Non-directional means you can't say which direction. And whether it is the orbital oriented, either X orientation or Y orientation or Z orientation. So this is spherical in shape. Either S orbital, all the S orbitals are spherical in shape. Next, P orbital, dumbbell shape. D orbital, dumbbell shape means only one orientation, any one of the axis, either X axis or Y axis or Z axis, only one orientation. Next, D orbital having two orientation, either XY or XZ or YZ, like either two orientation will be there. That's why L value equal to 2. And F orbital, L value equal to 3. So why L value means the number of the shape, how many shapes are available. S orbital, only one shape available, that is a 0. That there is no any directional shape, so that's why we are writing this is 0. And P orbital having only one direction, either X direction or Y direction or Z direction. And the D orbital having two lobes, then here having 5 direction, and this one having 7 direction. Then how it is for the 5 direction and 7 direction and all, next we'll see. Yeah, next. M, that means ML, magnetic quantum number. ML is nothing but magnetic quantum number. Here, S is a non-directional, then only one direction, that is 0. There is no any other direction. In P orbital, one lobe is there, either when you are writing the axis, X axis, Y axis, and Z axis. The lobe, it can locate in the X direction, or it may be located in the Y direction, or it may be located in the Z direction. This is called the L value. If it is X direction, then L value, that means ML value, ML equal to +1. Next, if it is Y direction, if it is this is Y, and this one is the Z. If it is Y direction, ML value equal to -1. If it is Z direction, ML value equal to 0. That means 3 orientation, either Z orientation or X orientation or Y orientation. So that's what I said before, how the orientation, how the orbital will be located in the particular region. And the next, same as it is, Z orbital also having that 5 orientation. The 5 orientation means I'll write the number itself. Yes, sir.
What is ML, sir?
What
ML.
sir?
What is ML?
ML. ML
Yes.
means magnetic quantum number.
Okay.
Actually, orbital means the probability of finding electron density in the particular region. When we are writing the this diagram, no, your shell we are writing, no. First shell,
Yes.
K shell we are writing, no. In that K shell, only one subshell is there, that is S subshell. How the S subshell will be there in the particular region, electron will revolve like this in the particular region. So how many electron it can revolve? Only 2 electron it will revolve. I don't know in the electron where it is revolved. In the particular region only electron will revolve. Understand, sir? The probability of
Yes.
finding nucleus,
Yes.
first shell. In the first shell means electron, it will revolve in the circular movement. Circular movement means first shell. In the particular region only electron will be there. How many electrons are there? Only 2 electrons are there. So this particular region we are calling as a K shell. That means one region, K shell. In that K shell, 2 electrons will be there. That electron will locate in the one subshell. That subshell name is called the S subshell. Okay, understand? So K shell means number n equal to 1. That means principal quantum number equal to 1. The in the principal quantum number, what is the orientation? How the electron will revolve? Is a circular motion. Continuously it will revolve like this. Then it is called there is no any direction. It won't revolve in the dumbbell shape or clover leaf. So it will revolve in the circular motion. That's why we are saying S equal to 1. Same here, N value I said, and L value I said, and next ML value. And last, S means a spin quantum number. S equal to either plus or minus. The clockwise direction or anti-clockwise direction. When the electron, when we are representing, when we will represent the electron, it will be first half of the arrow and down half of the arrow. So this first electron rotating in the clockwise direction, second electron rotating in the anti-clockwise direction. Okay. So next I'll explain clearly. For example, K shell, n value equal to 1, not this. Here n, here L, here ML, here S. Next, this is a K shell, n value equal to 1. 1 means L value compulsory it is 0. Why? Because only one value should write. If it is L value 0, ML value also 0. If it is ML value 0, here either the electron will occupy in the orbital 2 electron, either plus of or a minus of. That means 1 by 2. This is K shell. That's why we are writing 1 S, S 2. Why we are writing 1 S 2 means this is 1 is nothing but N, and S is nothing but L. How the orientation it is present? Okay, how the orientation? That means it is a spherical in nature. That's why it is a 0. Next, how many electrons are occupied in the shell? So 2 electrons are there. One is the clockwise direction and another one is the anti-clockwise direction. Next, when you are going to the L shell, n value equal to 2. That means a second shell. From the nucleus, second shell. How many subshell will be there? 2 subshell will be there. One is a 0 and another one is 1. 0 means we are calling as a S subshell. 1 is we are calling as a P subshell. Understand, sir? P subshell. Next, ML. Here there is no any orientation, different orientation. Only one orientation is there. That's why we are saying this is 0. ML value also 0. And 1 equal to P. That means only one P subshell is there. The P subshell having 3 orientation. What are the 3 orientation? One is +1, another one is a -1, and next one is a 0. So +1 is nothing but Px, and plus 0 is nothing but Pz, and last -1 is nothing but Py. So that's why we are writing S orbital having 1 box, P orbital having 3 box, and D orbital having 5 box, and F orbital having 7 box. 1, 2, 3, 4, 5, 7 box. Next, here everything having 1 box. It is degenerate orbital. Then every box will occupy 2 electrons. One is the clockwise and another one is the anti-clockwise. Then we can write here plus or minus 1 by 2, here plus or minus 1 by 2, here plus or minus 1 by 2. Clear? Understand? Understand, sir? Hello? I'm audible?
Sir, kindly repeat the last one.
Last one, ma'am.
Yeah.
1 second, ma'am. Next shell I will explain, then you can understand better. Okay, no? M, the
Yes,
value
sir.
is 3. That means a third shell. M value equal to 3 means is a third shell. The third shell means it's having 3 subshell. One is that first value. Here I written n value equal to 3. That means L value we should write 3 value. We have to start from the 0 onwards. 0 and next 1 and next 2. 0 means it is non-directional. It is we are calling as a S. And 1 means is a directional. We are calling as a P. Only one direction, either X direction or Y direction or Z direction. 2 means we are calling as a double direction. That means 2 direction will be there. Two direction will be there. then we are saying is a d orbital. First one is a S subshell, second one is a P subshell, third one is a D subshell. So overall, we got the 3 numbers. Next, the S subshell only one orientation. It is called a S orbital. Only one box will be available. The magnetic quantum number, that means ML value, it will be 0. Next here, P orbital having 3 orientation, either X orientation or Y orientation or Z orientation. X orientation we are calling as the +1 orientation, and Y orientation we are calling as the -1 orientation. Z orientation we are calling as the 0 orientation. Okay, when you are taking the 3-dimensional view, one is towards S, and another one is upwards, and next one is the right and left. So here we are saying Px orbital, Py orbital, and Pz orbital. So that's why yesterday I said S orbital will occupy only 2 electrons. Why? Because only one box. P orbital it can occupy maximum 6 electrons. Why? Because 3 orientation, 3 box. Next D orbital, 5 box. Here plus or minus 1/2. That means only one box, no? Then either plus or minus electron, and here plus or minus electron, and here plus or minus electron. So 1, 2, 3, 4. Next D subshell. When you are saying the D subshell, it's having value is a 2. Then 2 means the first you have to start from the +2. Second we should start from the +1. Third we can start from the 0. Fourth one we have to start from the -1. Next fifth one we have to start -2. So here the orbital we are saying dxy, and next dxz, next dz square, next dx square minus y square, and next dxyz. So overall 5 orbitals. That means overall 10 electron it can accommodate. You understand, no? Now it is clear. Now it is clear. And now I'll try with one example. Clear now, sir? No? If you have doubt, again I'll repeat. So here the first case, only K shell will be there. N value 1, L value 0, M value 0, then S value plus or minus 1. So 1s orbital. Next L value 2. L value 2 means that means second shell is the 2 values will be there, 2 orientation will be there, 2 subshell, S subshell, and another one is a P subshell. Next M shell, 3 subshell will be there. One is a S subshell L value equal to 0, M subshell P subshell L value equal to 1, and D subshell L value equal to 3. Suppose if you are going to the F orbital, that means fourth shell. If you'll write the fourth shell, then how we can write the electronic configuration? Based on this only they are writing electronic configuration. So for N value 4, then we can write N value 4 means L value equal to 0, 1, 2, 3. That means 0 means is the S subshell, and 1 is a P subshell, 2 is a D subshell, 3 is a F subshell. If it is this one means only one deviation, one orientation, and this one 3 orientation, and this one 5 orientation. This one 5 orientation. Next last one 7 orientation. 1, 2, 3, 4, 5, 6. Overall 7 orientation. So this orientation we are calling as this one we are calling as a N, and orbital we are saying as a L, and orientation we are saying as a ML, and how the electrons are arranged in the orbital is called the S. Clear? Is it
Yes, sir.
understand?
Sir.
Now with the example I'll explain. Yeah, quantum number, that is not there. Suppose if they will ask the question, what is a 3D orbital quantum number? 3D 2. Suppose if they will ask the question 3D 2, what is the n value, L value, ML value, and the S value? If they'll ask the question, what we can write? This 3 is nothing but n. And the D, already we know that D means the L value equal to 2. And the next ML value, how many orientation will be available? How many orientation? Then orientation, it will be plus or minus 2, plus or minus 1, and 0. Overall 5 orientation. This 2 electron where it will accommodate. So 2 electron means either in the particular orbital, overall 5 degenerate orbitals will be there. And first electron, second electron. Then we can write the ML value, S value either plus 1 by 2, and next also plus 1 by 2. We have to write like this. Clear? So suppose if they'll ask a question, then we have to write, and they'll ask a question like that one. Next is second question. So the first question, understand, no? In the modern periodic table, the period indicates the value of principal quantum number. Principal quantum number is nothing but the n value. N is nothing but shell. Shell means first shell or second shell or third shell. Okay. So if it is first, only one shell is available in the period means the first period, 2 shell available means true period. Next question, which of the following statements related to the modern periodic table is incorrect? They are asking. Which one is incorrect? The first, P black element, 6 columns are there, and the maximum number of electron occupied in the particular orbital, the p orbital, p subshell is 6 electron. Whether it is correct or not? Is it correct? Next option they give, the D block has 8 column, and because the maximum number of electron it can 8 electron will occupy in all the orbitals in each D subshell, they said. Next, each block contains number of columns equal to number of electrons that occupy subshell. Next one they are asking, P block indicate the value of azimuthal quantum number, and the last subshell have received electron in the building of electronic configuration, like they are asking. So among this, which is the incorrect question, incorrect option they are asking? What is that? Which one is the incorrect option? So yesterday itself I said, when you are saying about the periodic table, first we should know in the periodic table how many blocks will be there. The first one is a 3-dimensional periodic table. Here overall 14 elements are there. And next one, here 2 groups are there. The first 2 groups are S block. Next middle 10 groups will be there, and the next 6 groups. So S block having 2 groups, D block having 10 groups, and P block having 6 groups, 6 horizontal column, vertical column. Next year they are given the first, P block has 6 columns. Yeah, P block have 6 columns. What are the 6 columns? First element, boron family. Next, carbon family. Next, nitrogen family. That means called as nicogen. And next family is called oxygen. Next, oxygen family. Next, fluorine family. Next, neon, helium family or noble gas. Here, these are the 6 groups in the P block. So first, already they said incorrect option. So P block having 6 columns, and because the 6 electron will occupy in the P subshell. Yes, P subshell having 3 boxes. One is a PX, and another one is a PY, and next one is a PZ. So overall 3 boxes it can accommodate 6 electrons. Each box will accommodate 2 electrons, overall 6 electrons. So this statement is correct statement. It is not a wrong statement. Next one, D block have 8 column and 8 electron it can accommodate. So it won't accommodate 8 electrons. It will accommodate overall 10 electrons. How it will accommodate 10 electrons means, just now we discussed D subshell, the L value equal to 2. 2 means plus or minus 2. That means 2 values, and plus or minus 1. That means 2 values, and 0. Overall 5 values will be there. 5 boxes will accommodate each box 2 electrons. Then overall 10 electron it can accommodate in the D subshell. But here they given 2 electron. Sorry, 8 electron it will accommodate in the D subshell. So that's why this option is the incorrect option. So this only correct option. That means according to the question, we have to select B is the correct. Next, each block contains number of columns equal to number of electrons in the, it can occupy the subshell. Number of column means, suppose if it is a S column, 1S, it can accommodate the electron. How many electron it will accommodate based on that. That also correct statement. The block indicate the azimuthal quantum number and L value. So L value already I said, whether it is L value equal to 0, then only 1. If it is L value equal to 2, then 1 equal to, then it is 3. And next L value equal to 3, then it is 5. L value equal to 4, then it is 7. And imaginary orbital is the G orbital. The G orbital having 9. So odd number we should go 1, 3, 5, 7, 9, 11, like we should go that orbitals. Okay, clear? And next, third question. Which element has the most electropositive and most electronegative? So most electropositive, first element. First we have to select most electropositive. Second element we should select most electronegative. In the periodic table, this is a periodic table. In the periodic table, last year I said yesterday, here this is the most electropositive element. That means the most electropositive element means the electronegative value is 0.7 I said, one element. That element name is called as cesium. Next year, highest electronegative element. This is the right hand side top corner. Noble gas we should not take. Why? Because noble gas 0 electronegative. So we should not take the noble gas. And next element is the fluorine. Fluorine having electronegative value 4.0. So now, according to our option, cesium and the fluorine. So cesium is the lowest electronegative, is a 0.7, and the fluorine is the highest electronegative, which is 4.0. So that's why we are selecting this one. Why we are not selecting other element? Potassium and chlorine. Potassium is the third period element. Third period element means third period element of right hand side, left hand side, and chlorine is the third period element of right hand side. So we should not select. So in the periodic table, right side top corner and the left side the bottom corner. So that 2 elements only, most electronegative, one most electropositive element. Next, which of the following has electronic configuration NS to NP4? What is that NS to NP4? Now we have to see the general electronic configuration of the group. How we can go for the general electronic configuration of the group. Then you can understand. The first period number is called 1A. Second period number, second group number 2A. Next third 3A. Next 4A. Next 5A. Next 6A. Next 7A. Last one is 0 or 8A. Either we can say 0 or 8A. Now, first group means already we know that is a S block. The second group also S block. Your third group means S and P orbitals will be, p subshell will be available. Here sp, here also sp, here also sp, here also sp, and here also sp. So that means last electron will enter in the p subshell. Here last electron will enter in the d subshell. Here we should write here first period 1s, second period 2s, third period, first period 1s, second period 2s, third period element 3s, fourth period element 4s, fifth period element 5s. So like we can write. So here 1, 2, 3 it is changing. That's why we are writing n s power 1. Every element having only one electron in the group. So that's why ns1 is the first 1a group general electronic configuration is ns1. Next 2a group general electronic configuration ns2. Next 3a group general electronic configuration n s power 2. Why? Because the s subshell is completed and the p subshell going to start. That means 1, ns1. Next this group general electronic configuration ns2 np2. Next third one is ns2 np3. Same as it is last noble gas. Noble gas we can write same as it is here noble gas we can write ns2 np6. This is the noble gas general electronic configuration. Here they given that in our question
ns2
yes,
p4.
fourth question. They given ns2 np4. Then which element? So and one more thing you have to remember.
Coach.
1 second. So one more thing we should remember. This is called the alkali metals. This group name, first 1A group name is called the alkali metals. Second one is alkali earth metal. And here boron family. And this one is a carbon family. And next one is a nicogen family. That means pH. Handwriting somewhat different. So adjust. And next nicogen family. Next chalcogen family. And here last halogen family. Here inert or noble. So here they given ns2 np4. The first they given inert gas. Second they given chalcogen. Third one they given halogen. And the fourth one they are given inner transition element. So inner transition element is nothing but F block. So this is out of the part. So inner transition should not be the answer. Next inert gas. This electronic configuration 8th A group or 0 group element. 0 group element means electronic configuration ns2 np6. This is inert gas general electronic configuration. Next one is a halogen. Halogen means ns2 np5. This is halogen family. Next here they given chalcogen. Chalcogen means is the oxygen family. Oxygen family means ns2 np4. This is chalcogen family. So answer is B. Correct now, sir?
Yeah.
Okay. Next question number 6. They given UUP means, what is the UUP means? So UU means this IUPAC nomenclature. Up to 100 elements, we are following the normal according to the scientist name and everything we are following. After the 100 element, if it is more than 100 elements, if anybody will found, then they have to name the element according to the IUPAC nomenclature, International Union of Pure and Applied Chemistry. Based on the norms, based on the rules and regulations only, we have to keep the name. Here, here they given UUP. That means UUP means that is symbol name. The first we should know that what is a U, what is a P. They given the number 0 to 9. First one is a 0, 1, 2, 3, 4, 5, 6. Next one is a 7, 8, 9. So this is a number. So for this number, they gave the suffix value, suffix they given. So how we should write the suffix? The first one, if it is 0, then it is called a nil. N-I-L. Next, 2 means an. Sorry, 1 means an. 2 means by. And 3 means try. 4 means quad or Q-U-A-R-D, quad. And 5 means pent. And 6 means hex. And 7 means sept. And 8 means oct. And 9 is N, E-N-N. So these are the suffix we need to follow. The last suffix, after completing the number, we should add with the I-U-M. This one we should add as a suffix. Clear? Now we are going for the element. And here U they give. U means an. That means 1. U means 1. Here again U they give 1. And again they give P. Then pent. Then 5. So what is the answer? 115. Suppose if they'll give the option as the 105. 105 means how we can write? First one is an. Next one is a nil. N-I-L. U-N. U first. And next N. And after that P. Suppose if they'll give the second option, first one is U, second one also U, and the third one is a try. That means a T. Next 103, if they would have given 103 means first one is a U, and nil, N, and next third one is a T. So like we have to write the answer. Clear? Understand? Okay. This one understand, no? So first we should know that number.
Yes, sir.
0 means is a nil, 1 is the un, 2 is a try, 4 is a quad, and 5 is a pen, 6 is a x, and 7 is a sept, and 8 is a oct, and 9 is a n. So this abbreviation we should know that. Then we can do that. And next question. Atomic number of rubidium less than that of which one is the among the following, which is the atomic number of rubidium is less than that. So which is the less? We can write element. First one is hydrogen. Second one is a lithium. Third one is a sodium. Fourth one is a potassium. And fifth one is a rubidium and cesium. Last francium. These are the elements exist in the same group. Clear? So now here atomic number of the sodium, this one is 11. Atomic number of the krypton is a 36. Atomic number of the cesium means it is last element, no? Then before element we have to check. Already we know that yesterday I discussed helium first element, second element sodium, sorry, neon, next argon, next krypton, next xenon, next radon, last one is the organism. This number yesterday itself we discussed how to find out the atomic number. The first one is a 2 and the second one is 2 plus 8, then it is 10. Third one is 10 plus 8, then it is 18. And the fourth one is 18 plus 18. That means 36. And next one, 36. Next one, 36 plus 18. Again 54. Again 54 plus 32. Then 54 plus 32 means it is 86. And next 86 plus 32, it will become 118. So this is the atomic number. Helium, next element is a lithium, and neon, next element is a sodium, and argon, next element is a potassium. Next xenon, next element is a cesium. That means xenon atomic number is 54, then cesium atomic number 55. And here krypton atomic number is 36, rubidium atomic number 37. And next, what they given the element? Sodium 11, krypton they give, cesium they give, potassium they give. Potassium atomic number 19. So among the following, which cesium atomic number 55. So among this, which is the highest, the atomic number of rubidium is less than that of cesium is the highest atomic number compared to rubidium. Rubidium atomic number 37. So remaining everything less than the rubidium, only cesium having highest atomic number. So that's why we are selecting as a cesium is the answer. Okay, clear? And next, which of the following has the same number of electron in the outermost orbit? Outermost orbit means outermost shell. So first we should know the element. How we can identify the element. So based on that, we can identify. This one we need to work somewhat. So we need to remember. Otherwise, we can't be able to answer that question. First one, group wise. That's why I said first two groups we have to remember. After remembering the two groups, then two period, we can easily understand. The first one, hydrogen. This first group, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. This is the first. Second one, beryllium, next magnesium, calcium, strontium, barium, and radium. This is second group. Next, boron family, if you will take boron, next aluminum, gallium, indium, and thallium, TL. Next, carbon, silicon, germanium, tellurium, germanium, tin, and the lead. Next one, nitrogen, phosphorus, arsenic, Sb, antimony, bismuth. Next, oxygen, sulfur, selenium, tellurium, and polonium. Last one, chlorine, fluorine, chlorine, bromine, iodine, and acetylene. And last one is a helium, neon, argon, krypton, xenon, radon. So here they given which is having same set of electronic configuration. That means same number of electron in the outermost shell. Outermost orbit means same group element only will show the same number of electron in the outermost orbit. So what are the elements? It will belongs to same group. That one we have to remember. Then automatically we can write the answer. So first, this is Sp, antimony and the tellurium. So it should not be in the same group. Nitrogen and the oxygen should not be in the same group. And next, arsenic and bismuth. See in the down, arsenic and bismuth, whether both are the same group or different group. Here, arsenic, and this one is the bismuth. So these two elements are in the same group. So if it is same group, then it will show the same number of electrons in the outermost orbit. That means last orbit. So the answer is arsenic and bismuth. Okay, clear? And identify the lanthanide. So lanthanide series. Identify the lanthanide series means in the periodic table, lanthanide and lanthanide, two things they will ask. Lanthanide means only lanthanum, lanthanides. Lanthanum means only lanthanum, and they will ask the question whether lanthanum is a F black element or a D black element. Whether it is a black element or a D black element. So most of the people, they will confuse with the lanthanum whether it is S black or a D black. Why? Because they don't know the lanthanide. When you are seeing the periodic table, the first element they used to keep in the La in the first a black element. So that's why they will confuse with the whether it is a lanthanum is the first element or a D black element. In the yesterday itself I said, in the periodic table, 3-dimensional view, one is horizontal and another one is a vertical. So horizontally, SPDF will be there. Horizontal, the horizontal place, SPDF, this is S, P and D, next to P will be there. Vertical place, F orbital will be there. So horizontal and vertical, that particular point is called the lanthanide. So lanthanide series will start from the cerium onwards. That means the atomic number, how much atomic number they'll ask. So 190 it will start. Next 103. So 90 and 103. This is called the actinide. Next one here they are saying 58. So already you know that radion in the periodic table, when you check the periodic table, the first one 58 to 71. So last Lawrencium will end with the element. So this element is the lanthanide series. Lanthanum is a D black element. It is not a F black element. It's a D black element. Apart from the lanthanum, 14 elements are there. That 14 elements only we are calling as the F black element. F black and lanthanide series. And next, in which of the element is the highest electronegative element? Highest electronegative elements already we discussed. The fluorine having the highest electronegative element, which is having 4.0. Next question. Next year they are given which element having the maximum shielding effect and the outermost electron. Maximum shielding means it is a kind of screen. Maximum shielding. So for example, nucleus, first shell, second shell, third shell, and the fourth shell. When the number of the shell will increase, the shielding nature also will increase. That means screen also will increase. First shell having that means the nuclear force will attract the first shell electron very much, very attractive, and the second shell electron somewhat less, and the third shell electron somewhat less compared to the second shell and first shell. Fourth shell somewhat less. That means the screening effect it will increase from nucleus to outermost shell. Like the number of the shell will increase, then screening effect also will increase. Here the question. Group number 13, period number 2. Group number 13, period number 3. Group number 13, period number 5. And group number 13, period number 4. That means group everything is the same. All the option having same group. But only the difference period. Already we know that period is nothing but number of the shell. If it is number of the shell will increase. If number of the shell will increase, then automatically screen also will increase. Screening effect also will increase. So this is the answer. Next question. Give the general electronic configuration of D black and the F black element. D black means already once this one you have to note down. S black means the general electronic configuration NS1 to 2. That means the first shell means first group means NS1. Second group means NS2. That's why we are writing 1 to 2. P black element, the general electronic configuration NS2, NP 1 to 6. That means 6 groups are there. That's why I am writing 6, 1 to 6. Next, D black element having the general electronic configuration NS2, NP6, N-1, D 1 to 10. So this is called a D black element general electronic configuration. Next, F black element general electronic configuration. NS2, NP6, N minus 1, D, either it may be 0 or a 1. Why? Because lambda we are writing, no, next element it will show either 0 or 1, and N minus 2, F 1 to 14. Why? Because 14 elements are there. That's why we are writing 1 to 14. Now the general electronic configuration 1 to 6. Here general electronic configuration they given. The first question, N minus 1 D 1 to 10, 1 to 10, and NS2, N minus 1, N minus 2, F, N minus 1, either 1 or 0, or here NS2. See the first one, if it is D orbital, here P also we can include, but here they are not given the P, then we no need to bother about that. So N minus 1, the first one. Next question, next point they given, N minus 2, F, here 1 to 10, NS 1 or 2. This also possible. When it is possible means I'll tell later chromium. Suppose few elements only it will exist. Chromium, atomic number, chromium no need, zinc will take. Suppose if you will take the copper, atomic number 29, the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. Next, 4s1, 3d10. Why it is 3d10 means complete fill. When the d orbital going to have the electron either 5 or 10. If it is possible d orbital having only 4 electrons, then it will take from the 4s orbital. That means 3s next orbital, from the next orbital it will take 1 electron. Then it will become d5, either d5 or d10. Then it is most stable. That's why here actually we need to complete 2 electrons. Then here we should write 9 electrons. So here 9 electron is not a stable. Instead of 9 electron, when we are writing the 10 electron, it will be stable. That's why we are writing 1. So because of the reason, here they given n minus 1, 1 to 10, ns 1 or 2, either 1 or 2. Next n minus 1 f, n minus 1, n minus 1 d, n minus 2 f, n, and n minus 2 1 d 1 ns2. Next they given last is the correct answer. N minus 1 D 1 to 10, NS 1 to 2, and this is for D black element. And F black element means N minus 1 F 1 to 14. Why? Because 14 elements are there. And N minus 1 D 0 or 1, NS 2. So this is F orbital or F subshell general electronic configuration. So we can write 2 ways. One is this one, F general electronic configuration 0, 1. Here n minus, sometimes they will give F n s 1 or 2, n minus 1 d 1 to 10, and n minus 2 f 1 to 14. So this general electronic configuration of the fluorine, sorry, a black element. Okay, clear? Understand? If I want to discuss again this one, I'll discuss if you have any doubt. Okay. I need to go a little bit slow means okay, I'll go, not a problem. And next year, 12th question is a repeated question. The electronic, the elements of the group 16th and 17th. 16th group, 17th group they are asking. 17th group is known as halogen, and the 16th group we are calling as a chalcogen. So chalcogen and the halogen. This is the answer. Okay, clear? Sir, enough, no? Sir? Okay, remaining part we will discuss later. Suppose if you have doubt anything, just you have to post in the WhatsApp group, and I'll clear the doubt.
Okay, sir.
Okay, thank you.
Hello, sir.
Yeah, ma'am.
Sir, please
Yes.
share
What, ma'am?
share the first class video, no? Hello.
Which one, ma'am? Which one, ma'am? I can't.
Sir, please do share first class video, recorded video.
Okay, we'll share, ma'am. Thank you.
Thank you, sir.
Thank you.